So in this session, we'd like to continue where we left off, discussing about composite data type in Python, namely list, tuple, set, and dictionary operations. By list operations, by operations, we mean to say how can we read and write, how can we select data, search for data, how can we combine data of the same data type, like list and list, how do I combine them, how do I add an item, delete an item, select an item, right? So we saw a few examples, but let's dive into this discussion a little bit more than just superficial understanding. So continuing from where we left off here, okay, let me just quickly copy the values over. Okay, so I'm just going to create A and B, the two lists. So far, so good. All right, and no big deal, just creating the lists. Then I'm going to calculate the length. How many items are there in list A? How many items are there in list A? So we're just going to run this and see. So A is this because I've printed it out and has length of A, len A items, all right? And it has 6 items. We let Python count rather than we go and eyeball it 1, 2, 3, you know. Number one, letting Python count an explicit list like this kind of is unnecessary because we could have counted it and it won't change, right? But you never know because the next time when you maintain or update this code, you might just put a comma 9 again, you know, or put a comma 10 here. Then if you have hard coded 6 here, it would have been wrong. And then subsequently everything will be wrong too, or not reliable anymore. So it's better to let Python count for consistency purposes. Number two, len A itself is super fast. It's not going to take Python any longer than necessary. So it's very efficient. You know, it's not going to waste too much time. So don't worry about efficiency. Just do a len A, a len bracket, a list to get the number of items. And B has got, because of all the decimal places, we could have eyeballed wrongly and counted wrongly. But Python is super sharp, so not to worry. Next, we like to select items from the list. So getting the 4th item is A square bracket 3. So 0 always starts with position 0, 1, 2, 3. We should see a 2. We can also change second item. So we just simply say select. It's just like selecting the actually not second item, but the 3rd item, second position. Okay. Because when we say second item, human-wise, we count first, second, right? We don't say 0th, first, second. Maybe we should do that. But here, yeah, let's just stick with the English sense of the word. So the second position means 0, 1, 2. So that's exactly this. I want to change the 1, update the 1 to 88. So you simply put the selector on the left-hand side, which is super convenient. You don't have to run a set list item function of A, 88. You don't have to do that. Just, you know, very naturally, if you know how to select the item, you know how to just put it on the left-hand side of the equal sign and put the new value on the right-hand side. Okay, and remember, because a list can contain any data type, including composite data type, the assignment need not be 88. It could have been another list of a list of a list. You know, so it's totally okay. Python will just take it and erase, so long as you know what you're trying to do. Python will not have the problem, but do you have a problem with it, right? So that's the main issue. Now we can also, very importantly, remove or take away the 0, 1, 2, 3. 0, 1, 2, 3. Now it's correct. Remove the 4th and the 5th items. So the 1st, 2nd, 3rd, and 4th. So I want to remove 2 and 5 so as to get the fourth to fifth items, right? So 1, 2, 3, 4, and 5. So it's 3:4 by saying delete del, right? So the del is pretty smart. If you give it a selector, it will not delete the whole thing A. It will delete only that part of A that is ranged or selected by your slicing operator here. Now, we do want to include the fifth item to be deleted. Right now, we are saying 3:4. Remember, the ending index is not included in the operation, whether we are selecting reading or we are deleting, writing it off. So in this case, it only deleted 2 here. Question to you, how do I delete the fourth and the fifth inclusively? So that means the result should be 4, 3, 88, 9. How do I do that? That's right. In order to include the fourth position as well, we should just +1, right? So we should say 3:5 and run it again. And this time round, we see that 2, 5 are both being deleted, and that's okay. And what if I say 3 colon? Remember what that means all the way to the end. So starting at 3, 0, 1, 2, 3, starting and including this number 2 here, position 3, all the way to the end, including the end deleted. Right. So if we do this, then first of all, there's no error. Pop index, oh, sorry, because it affected subsequent operations. But up to here, we were trying to demonstrate a pop, and there's no more, not sufficient items here for the pop to happen. But up to here, it is correct that we don't see anything else after the 88. Yeah, because that is okay, that's understandable, and we shouldn't see any problem here. So maybe I should change back to remove the fourth to just the fourth item. Okay, so just the fourth item, we could have just said delete A:3 just as well, and that would be fine. Okay. Append with a B with B. So we now want to concatenate or expand the sequence of A. Now, because the sequence, the ordering makes sense, is significant, is important in a list setting. So A plus B is not the same as B plus A, because it will be reordered differently. So what we want is, we want to create a new list, C, right? And that starts with A, and that is appended with. So fortunately, we just do a plus. There's an abuse of the operator. The nice way of saying it is called overloading. So computer science terms have this graceful way of saying we are abusing the plus operator to also overload it with the meaning, in case A and B are lists, then we are supposed to use the plus to mean that we are concatenating them, stitching them together in that order. A first, then B. Now, if we just do A and B, we are doing the complete list stitching. But if we do all of B except the first and the last, because we don't want to include the first nor the last. So the way to say that is to say A plus starting from 1, because the first element is position 0, start from position 1, so skipping the first one, and ending at the last position, because the last position number, the value, is always not included, right? So in saying 1:-1, we managed to say everything in B except the first and the last item. So that's really cool way of really indicating what we want. What you say, what you want is what you get. That's nice. So we get a C and created a new list. Yeah. Next, we make a copy of C. We make a copy of C. What does that mean? We haven't seen what is D yet, right? So C and D. Because of subsequent demonstration, everything is kind of gone. Let's finish up the explanation first, then we see what's going on. So we make a copy of C. All right. We cannot use D equal to C. because what that means is for composite data type, the data themselves are contained in a structure. This structure, when you put equal sign, is the same. So for example, do we have an A here? We have an A here, right? So if I say A2 equals to A, so obviously A is still the same. A2, however, we shouldn't suspect it being different, right? But this is very illusional.